Hello, and good evening, good morning, wherever. All right, let's start. Hi, CJ. Good evening to you.
Maybe Mr.
All
Dennis.
right, how are you?
I'm tired.
Uh huh.
How are you?
Doing good. All right. So I recall last time you said that you wanted to go through topic two, which was mechanics, specifically forces. Right?
Yeah.
Okay. You would still want to go through with that, or do you like?
Yes.
All right. So let's go through that then. All right.
Wait.
Uh,
Can today be 1 hour?
1 hour. Sure. So we can cancel the second hour and move it when?
Thursday.
Thursday.
Because
Sure.
today I already had like 4 hours of tutoring and I'm
I
like,
see. Yeah. Okay. No
I had
problem.
enough.
No problem. All right. So hold on. Let me just share the Jamboard with you.
Thank you.
Okay. So again. Oh, by the way, um, last time, I kind of mentioned this previously, not last time, but previously that I was streaming our lessons and you were okay with it, right?
Mm-hmm.
Yeah, I am currently streaming it now. Currently streaming,
Mm-hmm.
and I don't know. I think I'm starting to get some followers.
Wait, actually,
Yeah. Um.
nice.
Well, it's not that I'm looking make it's not that I'm trying to really make it big, but getting those followers, one or two a week's nice. All right, so there's
Uh-huh.
the Jamboard. You should be able to edit that. Okay, so let's focus now on what you want to do, which was let me just share this. Okay, and let's go to the board. All right, so we're gonna do mechanics specifically. What was it? Forces, right?
Mm-hmm.
Which part was it
Yes.
about forces? Balancing forces. Okay,
Yeah.
okay, okay. Now, um, probably you're already aware that okay, there are two things that you need to do whenever we have this balancing forces. Okay, um, first thing is you must be aware of Newton's second law and first law. Okay.
Mm-hmm.
Yeah, what's wrong with my pen? Hold on. Okay. Newton's first and second laws, right?
Yeah.
Okay. And then you must be aware of the vector nature uh, of forces. You have to put these together whenever you're analyzing anything wherein you have two or more forces acting on an object. Okay. Hold on. Something is. I just want to change a quick setting here. Uh, all right. I think I'll change that real quick first. Give me a moment. Check that out. Okay. Okay. Give me like another minute here. Okay. There. So we'll update that. All right. So let's start now with how to do it. Okay. Now, what we can normally do here is for this to be really efficient. Okay. A technique I like doing. teaching, and a lot of students also like doing this through with this technique, yeah, is you need to resolve your forces, right? Resolve forces in x and y coordinates, right? And doing this will definitely take care of these two. Okay, now how do you do it? In table form. Okay, now why table form? Because if you think of this as a table, then you basically just think of this table as having three main parts. Okay, this I'm just gonna
Mm-hmm.
do this like that. The first part is here. I'm just gonna write x and y. So these are the degrees of freedom. In other words, these are your coordinates, whether it's the x coordinate or the y coordinate. In fact, you can extend this to 3 dimensions up to the z coordinate if you need to. Or if you're gonna go into math, you can extend this into the fourth, fifth, and sixth dimensions and everything. Okay. But for physics, in IB at least, this is going to be only 2 dimensions. In university, it'll go only like up to 3 dimensions. So you could have a z here, it doesn't really matter. Okay.
Mm-hmm.
So again, so the first part here is these are your, I'll just say this as directions, right? Okay. Now the second bit is here. Okay. This bit, we're gonna, let's just put the title here. These are the forces. Okay. You write your forces there in little subcolumns like that. Okay. So what happens in this particular section, in like the middle? So here you're gonna have, I think I'll type this in. Oh yeah, okay. So in this bit, these small sections will contain the components of each of the forces that you have. Each of the forces in the problem. Okay. Okay. So again, um, these guys will be like that. Okay. So these small sections here. Now, this part on the top will label or list all the forces that you have on the object. Okay, and then the third section on the problem is this. You're gonna write here the sum of forces. This column here is to use Newton's third law, Newton's second law rather. Okay, so basically you're either gonna write here it could be 0 or it could be some value of a force, right? Or just write MA. Most of the time you'll write MA or 0. Okay. All right. So that's all you have to do. Once you can do this consistently, it's going to be easy to resolve any 3, 2, 3, 4, 5, 7 forces. No matter how many forces you have, it's going to be really easy to resolve that later on. And then you can solve the problem by doing these. Okay. So let's go to a quick example. Okay. First example, I'm gonna pick a problem. Okay, you know what? I'll make this easier for myself. I'm gonna check online quickly for a physics problem. Okay, physics problems. Um, resolving forces. Balance. Yeah, resolving forces. Okay, physics word problems. Okay, let's add that word problem. Okay, give me a moment here to look for a relatively simple problem first. Okay, now the reason why I'm checking the internet is because all these problems more or less always are in one one of several major forms, but the situations are different for each case. Okay. All right. So
Mm-hmm.
let's kind of look at this. Okay. So for those, okay, this is for the benefit now of those on the stream and also for yourself. Okay. I'm gonna put the link where I'm looking at it now. I'm gonna put the link to the problems here. Okay. So here's the first problem. All right. The link first. The link that I'm looking at is here. I'll just post that here. Okay. All right. First problem is this. Okay, so you have a computer base unit, the mass. Hold on, it's still loading here. Let's try that again. All right. So let me read the problem while this is loading. So, oh, there. So you have a computer base unit of mass 4.5 kilograms is dragged along a smooth desk. So the word smooth indicates there's no friction. Okay. Now, since it's being dragged, then you could assume that the person is pulling it with two arms. Okay, so if the tension in each arm of the person dragging it is 16 newtons and acts at 22 degrees above the horizontal, what's the normal reaction force? Okay, so um, the first part is not the table. The first part is always your free body diagram. So let's draw the diagram. So step one, draw diagram. Okay, what kind of diagram? This is called the free body. Well, not yet. This is still the diagram for the actual problem. Okay, then followed by the free body diagram. Okay, so that's step two. So first of all, there's your object, there's your computer case or computer base unit. Okay, what are the forces on it? First is the automatic weight, that's mg, right? Okay, since it's a smooth desk, no friction, we don't have to draw the friction, and then there are two values of the tension. So I'm just gonna draw two arrows, just like that. So both of them are T, right? Okay. Now, why do we have to draw the factors like this? Because first of all, it actually mentions here that the angle between the force and the horizontal is 22 degrees. So we have to label that 22 degrees right there. 22 degrees. Okay. So if we draw the free body diagram, let's just convert that. The free body diagram is now just a dot or just a box. I prefer dots. But if you want box, I think in this case box would be better. Okay, so if we draw the box, what do we get? Mg is going to be like that. We're labeling it like that. And then our two tensions, we can draw it separately like that. So T and T. Okay, and we know that this is 16 and this is 16 newtons. Okay, what's mg? That's going to be 4.5. For g, again for ib, just so we're clear, we don't really care if you use 10 or 9.81 for the value of g. Okay, but to be safe, we need to use 9.81 for word problems. Okay, word problems. In other words, for those doing IB, this is for paper 2. Okay, if you're gonna do this in MCQ, okay, in MCQ, use 10. Why? Because you're not allowed a calculator in the multiple choice paper, and therefore make the math easy for you, use 10. Okay, so now that we have the free body diagram, oh, by the way, let's put that in the calculator real quick. What is 4.5 times 9.81? That's gonna give us 44.145. We'll put it here, 44.145. We'll write the whole thing first, so it's easier for us to get a more accurate answer later. Okay, 1.5 newtons. Okay. Let's put the newtons here, and we know the angle is 22 degrees. Okay, 22 degrees. Now, the third step is the table. Step 3, table. Okay. So what are we going to set up again? First is x, y, x and y. And then we're going to set up our forces. We have three forces. We have the weight, mg, right? And then we have two tensions, but I'm going to draw them, or rather not, I'm going to write them separately like that. So those are our three forces. So even though these two tensions are equal, it's going to be useful to write them on separate columns of the table rather than you think about it like two pieces of the tension. Okay. So the last part here is I'm just going to write some of forces like that, or resultant force like that. Now, going back to the free body diagram, I think I'll copy that real quick. So, okay, I'll copy the free body diagram with the values needed. Okay, so now that we have the free body diagram like this, okay, it's 44.145. Okay, so we can see the directions. First of all, mg, it's all downwards, right? So we're gonna write that here as minus 14.145 on the y direction, and then on the x direction that's gonna be 0. It's got no component in the x direction. Okay, so the second one, the two tensions, they're gonna be identical. So let's kind of zoom into that. So that's again the tension here, and we know that's the 22 degrees, and this is 16. Okay, newtons. So if we're gonna look for the two components, the first component goes to the right. Now, if you're still struggling on seeing where is it going to be left or right, all you have to do is look here. All you have to do is look here. This vector is pointing generally to the right. See, it's going that way, which is to the right, generally speaking. Also, it's going up. So those are your two components. One component's going to go up to the right, and we'll label that Tx. And we're going to do Ty because it's generally going upwards again, so Ty will go up. Okay, so our x direction, this is going to be Tx, and that's going to be Tx, which is equal to T cosine 22 degrees. But T, we know T, it's 16. So we'll just change that T with 16. Of course, we can solve that actual value. I'm going to put that actual value in here, okay, because they're equal. So similarly, this is going to be Ty. So this is Tx, right? This is Ty and Ty. Now Ty is pointed up, so we'll give it a positive sign. So the hint here is what? Up or right should be positive. Down or left should be negative. Okay, that's why we have negative here. It's downwards. Okay, so in this case, if we put that in, let's find the cosine of 22 first. Let's get to the calculator. 22, let's find the cosine of that. Cosine, right? Times 16. So the answer is 14.83. Let's go all the way to that first. 14.83. Okay. Similarly, this is going to be for Ty. That's going to be 16 sine of 22 degrees. And if we put that in the calculator, so let's do that again. Where's the clear? Okay. So 22 degrees, find the sine, times 16 equals 5.99. 93, so 94. Yeah, I will put it at 99. We'll keep it there. Okay, so that's the whole idea. Now that we have done that, question is, it's being dragged along. Okay, So if we go back to the problem, it's asking us what's the normal reaction force, right? What's the normal reaction force? Oops. Okay. So we forgot something in our diagram, but I'm going to put that in there just to really emphasize the point. Okay. The normal reaction force is going to go up, right? And we don't know what that is. So we're going to have to draw our arrow pointing upwards, and we don't know that, right? So we're from there, we're going to add another column here on our table before we do the sum of forces. Okay. So we're going to add the normal force here. It's going to be 0 here on x. Again, because if you look at the diagram, it's vertical. So no component on the horizontal, right? And since that's what we're looking for, we'll just keep that as n. We don't need to actually look for any other value for it. N is unknown, right? So let's keep it like that. Okay. So finally, our sum of forces side, um, mg on the x, we don't really know, but so I'm just gonna write ma. And then for y, we know it's not moving up or down, so it's gonna be 0. Okay. Now we're not really interested in x right now, but it's still a useful exercise to set up the table every so often. The only part you will actually need, for now at least, is the y value. Okay. So if we go back here and just copy y, we get 14.145 negative 14.145. Okay. Then we get 5 point yeah, let's just use the 5.99. So two of these, 5.99, then another 5.99. And then we get n, and then we know that the sum is 0, right? So let's just label this again. This was the weight. This is tension. This is tension. This is the normal contact force, and this is sum of forces. Okay? So all we're going to do now is actually write this out as an equation. So I'm going to do sum of forces. That goes like that. And all I'm going to do is actually copy those numbers with the sign. So I'm going to put plus, plus, and plus here. Why again these pluses? They're all upwards. Okay? And then this is negative because this is downward. So all I'm going to write down is just that, 5.99 plus 5.99 plus n uh, minus 14.145. And that should also be equal to 0. Okay, and from here it's very simple algebra. We add those, we just put those numbers together. N will, we isolate n, we get 14.145 minus 5.99 minus 5.99. And if we put that in our calculator, 14.145 minus 5.99, oops, let's do that again. 14.145 minus 5.99 minus 5.99. That gives us 2.165 newtons, and that's the answer for what the value of the normal contact force is. Okay. All right. Does that make sense, CJ, for the whole thing? I just showed you the whole thing, so I know it's a lot to take in. So if you had any questions from any of that, let
So
me know.
yeah.
Go ahead.
Okay, so when you drew it,
Let's go back to the drawing. Yes.
okay, so when you drew it, would the normal force just be the line like opposite, not opposite, but like in the other direction of mg? So normal force is like the force
Hmm.
pushing you back, no?
In most cases, yes.
Normal force is that R.
Yeah, or
Okay.
some people use R,
Um,
some people use N. I think you're comfortable with R, so I'll use R. Yeah.
yeah.
So
Is the normal force perpendicular to the gravity or the surface?
surface. It's always the surface. Now,
Okay.
I'm gonna say that 80% of the cases that you have, R and the weight are opposite each other. But there are certain cases, 20% of the cases wherein they're not. Okay.
Hmm.
All right. Okay. So Let's
Okay.
go to the not.
Yeah.
Okay, so anything else before we go to another problem?
Yeah. There was when you find R,
Mm-hmm.
you find the on you highlighted the red on slide 4.
Slide 4. Oh, yes.
It was the TX, TY. It
This
was
bit. Mm-hmm.
yeah, it was the red highlighted the
Uh-huh.
vertical line.
All right. So I'm
Use
going.
that to find R.
No, that's to find the tension. Okay, because remember, go back to the problem on the tension only. The tension is actually, this is it, right? So the tension's there,
Mm-hmm.
and we want to find the components of the tension. And how do you do that? You basically just make a right triangle like so, right? So
Yeah.
this is gonna be Tx and this is gonna be Ty. Now what's Tx gonna be? Mathematically speaking, you have to make sure that this is going to, that Tx and Ty put together, added together gives you your T, right? Now on a more practical side, how do you think about it? Again, T is going, I'll write it here, pointed, pointed upwards and to the right, right?
Mm-hmm.
Okay. So this means the components, the individual components, must point in one of those two directions. Okay. Hence, um, hence, what we will do is Tx is gonna point to the right. We're gonna choose right for Tx. Okay. And then we're gonna choose upward for Ty. All right. So on the table, what does this mean? So if we go back to the table and set it up before, I'm just going to put t, x, and y here. Okay. So in this case, from here, I'm going to say this is tx, and that's equal to, let's put that value of, general value of theta there, right? So this means that tx will be t cosine theta, and then you can solve for the actual value if possible, right? And then for y, we're going to write ty is equal to t sine theta. So again, to clarify your question, this diagram doesn't show you the resultant, rather the normal contact force. This diagram shows you the components of T. Okay.
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 Yeah.
Okay. Anything else at the moment?
Can I see slide 5,
Okay, sure.
please?
Hold on. I'll just move this slide. Okay, slide 5. Going back.
That symbol, the E,
Oh,
backwards E,
this thing.
is that resultant force?
Yeah.
Or what is
Okay,
it?
let me get that.
Yeah.
Let me put that on a separate slide. Okay, that's a good question. So I'm just gonna write down how that looks like. And this is Newton's second law, right? Newton's second.
F equals ma
MA.
for the momentum.
All right. We're we much we're much better off to actually saying change in momentum over change in time. But that
Yeah.
results to that in constant mass anyway, right? So for now, we'll use the MA version. Okay. So what does this mean? This is the Greek letter sigma, okay, which symbolizes sum. Okay.
Oh, the sum of F.
Yeah. But because remember, since F is a vector, so the sum of several forces is the resultant vector. Sum of several forces is the resultant force. Okay. So because of this, we call this thing the resultant force. Okay. So Again, that's the
Mm-hmm.
notation. The sigma part comes from math. It doesn't really come from physics. It comes from math.
Mm-hmm.
All right. Any other questions?
Mm, I think we should like do problems and then I'll
All
ask
right.
along.
Okay. So this is what I'll do. I'll post another problem from the same source. Um, I'm gonna pick a slightly easier problem. Hold on. Okay. This is similar to what we've done, but we're looking for something else. Okay. Okay. So CJ, I want you to try this out first. If you have questions on the way, along the way, just ask. Okay.
Oh,
All right. So do again. I will help you out by telling you what to do. First is diagrams. Okay. So this includes two parts: the free body diagram second,
sure.
but the problem diagram first, right? Okay.
Mm-hmm.
The second part that you would need to do here is the table. Okay. So, and then the last part is solve. Okay. All right. So while you're working on that, I'm going to wait, hold on. Okay. So while you're working on that, I'm actually gonna work on this separately for our reference later. Okay.
Okay.
Okay. So keep in mind, just a big clue here to make it easier for you is there is no resistance to motion, and that the
So
parent
there's no drag.
no drag, no friction, nothing like that.
Okay.
All right, I'll put another tip here. Put another tip here. R and mg are always present.
Would I draw two triangles or one triangle
Okay,
for like the angle?
you can do one.
Hmm. Is it the one between R and the parent pulling?
Mm-hmm. Correct.
Okay.
Okay, so while you're working on that, I also want to just say something about the stream thing. Just don't worry about it. The only thing that people have access to is your voice. They don't know and your first name because I call you your name every so often, right? But no
It's
other
okay. It's my
detail.
nickname.
Yeah, no other details come out. Not your face,
Yes.
not your email address, nothing. Okay.
Okay.
All right. So everything's safe, hopefully at least.
Yeah.
All right.
Could I? Okay. This is gonna be weird, but I
Yep.
want to use. This is what I would do in Math AI. I would use Pythagoras, and then I would use cosine law
Go ahead.
or cosine rule.
Go ahead. We mentioned this last time. Last time we were studying together, right? If you can use
Mhm.
any math tricks that you've picked up, to make stuff, make solving easier, go for it. You're not gonna get penalized anyway. The important thing is you were able to get your numbers properly.
Mhm. Okay, I'll see.
Okay. Okay, so excuse me, stream. All right. So while CJ here is working on it, let's work on it together here. Okay. We'll just see when he's done. We'll continue from there. But for now, while we're waiting, how would you solve it? Okay. So basically, you're gonna start off with diagram again. So you have your child on the sledge. Okay. You have your child on the sledge here. So that's the ground. That's your sledge. And what are the forces on the sledge? We have the weight. Then we have the parent pulling, so we'll call that F. And then we have the normal contact force upwards. Okay. Again, we'll follow CG's notation here. We'll use not N. My preference is N, but let's see. Yeah.
Mr. Dennis, do I have to find 20 times 9.81, or is that irrelevant for this?
Um. All right. Let's make this easy. Let's use G equals 10 for now.
Okay,
All right.
so just 200.
Okay. So for now, since
Okay,
we're so what are we gonna
so
do
does that
here?
mean I do like 200 cosine 125? No, that's
No,
wrong.
no, no. You're looking for that angle.
Ye- Wait, from MG to parent pole or from R to parent pole?
That angle should be from the horizontal because it's given there. It's given here that the angle theta is to the horizontal. So let me help you out there. Okay. So this F should be like this. So the F should be. Oh, sorry. Let's put it.
Hmm.
So the F, uh, and that's your angle, should be somewhat like that.
Yeah.
Okay.
And is the okay, is the hypotenuse 125 Newton?
Right. Correct.
But the vertical, hmm,
You're gonna have to
the
look for those,
not the
right?
vertical,
Now I'll give
the
you a hint.
R, the normal.
Yeah, the normal contact force should be what?
You said it was perpendicular to F.
No, it's always perpendicular to the surface of whatever your object is on.
Okay.
Okay. So it's not perpendicular to a force, okay? It's always
Mhm.
perpendicular to a surface. All right. So back to stream. So while we're waiting, here's the idea of what I was talking about. So the F would go like this,
Um,
and we're looking for theta. The weight would be
Okay,
this.
so is
So
the height, not the height, but is the opposite of the theta like mg, or would that be like what?
not
I
quite
don't
yet.
know.
Not quite yet. All right. So think about it this way. Remember when we go back to the table, we don't really care about what is what. We just want to see which ones are vertical, which ones are horizontal. And we just need to label
Mm,
to write down all our forces, right? So
yes.
how would you set up the table here? Okay, I'll help you out with the setup of the table. You fill it in, okay? So the table should be set up like so. It's still XY, but if you are very careful with your diagrams, then you should have your weight, you have your um, R, your normal contact force, and then you have the force from the parent. And then of course you have at the very end your resultant force, right? Let me make this a bit smaller.
Mm,
You have your weight, you have your R, and then you have the force from the parent, and this should be sum of forces. Okay. All right. So fill that table in,
um,
and then
wait, so weight for y is 200.
okay. Don't forget the signs. All right. So
Science,
yeah, positive or negative.
negative 200.
Okay. So this is gonna be negative 200 on x. What should that be?
0.
0. All right. Then R.
R for x is also 0.
Okay. Correct.
It's positive 124.5.
How do you get that? It's given, right?
Yeah.
So we'll put the positive there. 124.5. Okay, so given. All right. Now, how about your two forces? How about your force from the parent?
Yeah.
Okay.
Um, the x plus y ends up
Mm-hmm.
being 125, but we don't know. So at okay, is it like 125 cosine theta? No,
Mm-hmm.
no.
Which one is cosine? Which one is sine?
Is it
This
125?
is right. It is. It is.
Cosine's the one to find for the
So both of them should be
x,
125, right?
x.
So go back. Which one is fx and which one is
Yeah,
fy?
fx fx is cosine, isn't it? Like from what I saw.
Uh-huh. Correct. Cosine theta, right? And
Yeah,
fine. Okay. And then
there's sine.
this one is
Yeah,
sine theta. Correct.
sine theta.
Right? So one what else is given? What else is given? No
Uh,
resistance to the motion. What is no theta? Okay. This is where. Okay. Can you assume that the sled is moving at a constant rate or not? Right? Can you
yes,
assume that?
um um um
You never assume that.
let's see.
If it's not given, you never assume it.
Okay.
Okay. So okay, I'll go to the next slide just to fit that in. I'll take this out. Okay. So far that's correct. Yeah. So all right.
Mhm.
0, 0, 125 cosine theta. So x w r, the force, the sum of the forces, um, y. So 0, 0, 125 cosine theta. Okay, you can see that this cannot be 0. Anyway, you cannot be 0. So you just have to write that as ma, but along x. So we'll label the acceleration along x max. Okay. Uh, okay, so if we go back to y, you have negative 200, 124.5. So negative 200, positive 124.5. Let's put positive here, by the way. Then this would also be positive 125 sine theta, right? Now, think about it this way now. If you have a sled and you're pulling it, you're not actually lifting it, you're pulling it horizontally, right? So this means the sum of forces along the
Yeah,
y
you are.
direction should be 0.
Mm-hmm.
All right. So from here, what can you solve? Which, so again, which one is the useful side? The x direction or the y direction? Which one's useful?
X?
You could find x, but you don't know the
Or
acceleration
is it
along
not?
the x direction, right? In this case,
Uh,
we don't know ax, so not really useful.
mhm.
I'll give you a clue.
But for
Whenever you
AY,
see a
it's
zero,
9.81.
yeah, whenever you see a zero on the sum of forces side, that's useful. Okay,
If I see the sum of forces on what?
if you see the zero here on the sum of forces side, this, that's a useful, this whole thing is useful normally. All right. So, okay, what do you do from this at this point? What do you do at this point? You just literally add those components up.
Oh,
So all you have to do is write those down in
really?
form
Like,
an
oh,
equation.
negative 200 plus.
Uh-huh.
Okay.
All right. All right. So if we put
Wait, 125 plus sine 125 sine theta
mm-hmm,
or 125 sine
sine
0.
theta. Well, you don't have to put this in the calculator yet. You have to write down the equation first, right? So what equation will you write?
Yes.
All right. So what equation did you write?
Negative 200 plus 124.
Plus 124.5.
I wrote the whole entirety of bottom, the y.
Exactly. You write it exactly as you see it. 125 sine theta equals 0. Now you want to isolate the theta, right? In math, you want to isolate that. So we're
Hmm.
moving everything to the other side. This 125 again as well needs to be moved. Okay. So let me clear everything. I forgot something. So that's gonna be that my minus 124. Then and second function. Okay. All right. I've just shown the stream how to do it on the calculator. Let's see if you get the same answer.
I got 37.2 using my method.
Correct. That is correct. Theta is 37.2
Hmm.
degrees. Okay. All right. Great. Theta is 37.2 degrees. Done. Okay. Um. All right. Is that getting a bit clear now how you solve forces using this technique?
Yeah,
All right.
just write down all the like write down all the values you're given on a
Mm-hmm.
table
Mm-hmm.
and try to find the x and y's.
Yeah, and
Then that's it.
and then after that, look for something useful that could find you whatever you're looking for. Okay. Now, I want to
Mhm.
recap. No, not recap. I want to ask you first. So, what's easier now? Whatever technique you've learned before, or this table technique?
Table technique, 100%.
100%, because it's a no-brainer once you know how to use it properly. It's a no-brainer. Just put the values in and done, right?
Yeah,
Okay.
very different from what my teacher was trying to do.
Uh, anyway, just so we're clear, it's not that what your teacher's wrong. What your teacher's trying to do is wrong, because this table is based on that exact
Yeah,
way of
it
thinking.
is, but the visualization is different for
Yeah,
me.
the
Like,
visual and thing is, I've
I don't
taught
know,
this
it's
to
more direct.
HL. Exactly, it's more direct. I've taught this to HL students and I've taught this to SL students before. Both levels would say like this is a lot easier if you do it like this. Okay.
Yeah, I don't know. It's like less memorizing.
Exactly.
I don't know because like I have to remember that like oh if it's I don't
Mm-hmm.
know, but I just
Okay.
know I have to remember. I don't
All
know
right.
what I have to remember though.
So anyway, since that's basically it, I can give you one more problem to do. You can do this on your own later. But for now, I think
Okay,
this is the last one we can do. Okay. Um, all
okay,
right. Hold on. Let me get one more problem. One that's slightly different. Let me see. Okay. This one's similar but different enough that you have to solve it all over again. Yeah.
hmm
Okay. So okay, so that's the last problem. You can do that on your own if you and then just show me the. I'll show you in chat. I'll tell you in chat what the final answer is. Or
Oh,
better yet,
thank
I'll
you.
just tell. Better yet, I see an answer key. I'll just tell you the actual answer. The final answer here is 98 newtons. Okay, so I think I'm gonna
Okay,
the assumption here is G is equal to 9.81. Yeah, so assume this. If that's the assumption, that's the answer. Okay. All right.
okay.
All right. If you do have a question later on, just let me know. Okay. All right. So last thing about our lesson, I've already moved the next hour later today, and then once this lesson is done, I'll change it to next Thursday. Okay.
Okay.
All right then. So any questions?
No, that's it. Thank you.
All right.
That
Good.
like that was good. Thank
Yeah.
you.
All right. So I'll see each other again on Thursday. Okay. I'll see you
Yeah.
then.
Bye.
Bye bye,
See you.
CJ.
Bye.
All right. So for the stream, I'm going to solve this as well. Just real quick on how to solve it, just to show you again one last time how to do the. Hold on, my pen fell. All right, how to do this table technique. Again, the table technique is a very useful tool because it makes everything more visual. It's not just logical anymore; it's also visual. Okay. Um, let's do this quick. First, I'm gonna go straight to the free body diagram. This is your object. That's your child on the sledge. Okay. Um, so the weight that's gonna be equal to uh 18 times 18g. I'll just say 18g for now. I'll do the solution later. Now, what else is given? The normal contact force, N, or let's use R again. Okay, that's gonna be 135. Okay, and given that there's no resistance to motion, so no friction, the parent pulls with a force of F. The F is here, and we don't know what F is, but we know the angle. The angle is 25 degrees. Okay, so let's set up the table. I will not solve this all the way. I'll leave the rest of it to you, but I'll set the table up again just to see, just to show you again how it's done. So if you understand it already, this is to confirm what you know. Okay, so again, we do X and Y. How many forces do we have? Three. So we're gonna have R, W, and F. and then we do sum of forces. Okay, our r, x direction is 0. That's positive going up in y, so 135 here. For the weight, also 0 on x, and on y, let's put that in the calculator. That's what's 18 times 9.81. That's gonna give us 176.58. Let's write the whole number in for now. 6.58. Now, in our case, we don't, let's kind of zoom into F. F is something like that. So that's your 25 degrees. You don't know F. So we'll just label this as Fx, and that's equal to F cosine 25 degrees. And similarly, this is Fy going up. That's F sine 25 degrees. So we'll write that into here. So again, F cosine 25 degrees, positive because it's going up. And then this is F sine 25 degrees. Again, positive because it's going up. So going to the left, sorry, going to the right, positive, going upwards, also positive. Now, sum of forces. We don't know for x. We'll just call that MA. Again, let's put x as a label. Then furthermore, for y, again, same idea. When you're lifting or when you're dragging something, it's not really moving vertically. So we can say that's 0. Okay. So finally, let's solve it. Which side's gonna be useful? The y side's gonna be useful for now. Okay. So what is F? Very simple. We do the same thing. Oops, I forgot something. There should be a negative here, right? So let's put that in. So that's going to be 135 minus 176.58 plus F sine 25 degrees should be equal to 0. Then we solve for F. So this is 107. We'll just do it like that. F is equal to 176.58 minus 135 divided by sine 25 degrees. Okay, putting that in the calculator, we already have the 178.58 here, minus 135, then divided by the sine of 25 degrees. That gives us 98.3 newtons, which rounds off to 98 newtons. All right, I hope that's clear to you on the stream. CJ, if you're watching the stream, I will be sending the link after I complete the stream. You can check this out. I'll let you know on the chat as well. Okay, everyone else, hope you learned something, and I'll see you again next time. Enjoy being freaky.